In the final lesson for Unit 3, today we're going to solve systems by using matrices. A matrix, you might recall from Algebra 1, is a rectangular array of numbers that's written within brackets and usually named by using a capital letter. Here I have matrix A with the elements 2, 3, 5 in the first row and elements 1, 0, 4 in the second row. A is a 2 by 3 matrix. That's how you read this notation here. So every item listed in a matrix is called an element. And an element is identified by its position inside the matrix. So with this notation in matrix B, B sub 1, 1 tells me I want the element in matrix named B in the first row in the first column. This would be in the second row, first column. This is the third row, first column. And over here we have the first row, second column, second row, second column, and third row, second column. So noting that notation. Let's give that a practice here. So I want to identify the elements based on that new notation from matrix A. So A sub 12 means the first row and the second column. So the first row, second column, that element is 5. In row 3, column 4, we want the element row 3, column 4. Row 3, column 4 is 0. A sub 24 is row 2, column 4, that would be 6. And A sub 43 would be row 4, column 3. So this one is not possible because the notation is indicating that we have 4 rows, and this matrix is a 3-row, 4-column matrix. We can also use a matrix to represent a system of equations. Each row represents an equation in standard form. So here in rewriting this system of equations, we could make our brackets, and row 1 would be the elements 2, 3, and 9. Row 2 would be the elements 1, -5, and -2. So you can see how the system is related to the matrix. Now normally where the equal signs are, you'll see a vertical line there to denote this is the break in the system. Let's look at example 2. We want to write a matrix to represent the systems. So in this first case, matrix A, we could call it matrix A for example A, would be -4, -2, 7, and then in row 2 would be 3, 1, and -5, and then the vertical line to break for the equal sign. In example B, you have to be careful there because we have some missing numbers. So matrix B, in row 1, we have 4 for the X term, -1 for the Y term, 2 for the Z term. There's going to be a bar for the equals and a 1 for the constant. In row 2, we have nothing for X, so we need a placeholder, 1 for Y, 5 for Z, and 20. In row 3, we have 2 for X, but we need to add 1 Y to the left, so we have 1 for Y. There is no Z constant, and 7 is our constant in the far column, in the fourth column. Now you should be able to go backwards. By looking at the matrix, we know that 2x and no y equals 6, and we know 5x minus 2y equals 1. So this is our system that's related to matrix A. In part B, we have x plus 3y plus z equals 2. We have x plus 2z equals 8. And then finally, for the third equation, we have 2y minus z equals 1. So a system with 3 equations, 3 unknowns. Now, when we're ready to solve using a matrix, we want to do row operations, and we want our final matrix to be simplified in what's called as reduced row echelon form. And here is an example with a 2 by 2, 2 equations, 2 unknowns, reduced row echelon. And here's reduced row echelon when there's 3 equations and 3 unknowns. Now, you have to be able to explain the meaning when you have the diagonals of 1 and all the elements under and above are 0, as in both cases. So we do have that here, this triangular array. And what this means is that our variable x is equal to 4. So we know in this final solution in reduced row echelon form, x is 4, y is -1, and z is 3. So we happen to know in reduced row echelon form, we have an xyz ordered pair. That's the solution to a system of equations with 3 equations and 3 unknowns. Next, we want to practice some of those row operations. It's possible to switch any 2 rows. It's possible to multiply a row by a constant, add 1 row to another row, or you can combine any of these operations. For example, if we want to solve this system of equations using row operations, I first need to write my matrix 9, -2, 5, 3, 7, 17. So here's my initial matrix. And if we multiply by -3 and add to row 1, let's write that down. We're going to multiply by -3, and we're going to add to row 1. So 3 times, this we're looking right here, 3 times -3 is -9, 7 times -3 is -21, and 17 times -3 is -51. And if I add that to row 1, we're going to end up with nothing here, -23 in the middle, and -46 here. Now, to save space, I'm going to erase all of this, but what we've done now is I'm going to keep row 1, 9, -2, 5, and I've just replaced that with my new row, 0, -23, and -46. Okay? So my goal is to get reduced row echelon form. And remember, with a 2 by 2 matrix, I want a 1 here and a 1 here. The other elements are 0, and then I need an x number and a y number. Then I know I've found my solution. So what do you notice about 23 and 46? You see a relationship there? That if we divide by -23, we can get a new matrix. So we could keep 9, -2, 5, and this would be 1. And if I divide -23 by -23, I've got this 1, which is one of the things I'm wanting. I want that 1. And then -46 divided by -23 is 2. Okay? Now what else can we do? So looking at our situation here, and again, trying to save space, what I would like to do is I'd like to multiply row 2 by 2, and I would add that to row 1. So if we keep, I'm working over here now, if we keep row 2, if we keep row 1 as it is, and I multiply this by 2, I get 0 times 2, 1 times 2, and 2 times 2. And when you do that, then you can see we're going to end up with 9 0, and 9. Okay, so let me erase some of this. And that's going to give us the same first row, 9, -2. No, I'm sorry, we're going to replace that with row 1. We're going to get 9, 0, 9 for our first row, 9, 0, 9, and 0, 1, 2, because remember we are allowed to combine or switch rows or add one row to another row or combine any of those operations. Now, the final thing I want to do is I want to divide row 1 by 9. So 1, 0, 1, and 0, 1, 2 gives me the reduced row echelon form. X is positive 1 and Y is positive 2. So we found our X, Y intersection for the two lines would be at 1, 2. And how did we do that? First we multiplied row 2 by -3 and we added that to row 1. We replaced that. Then the next thing we did was we divided by -23. Let's just show divide by -23, and that gave us this new row 2. Then we multiplied row 2. We multiplied by 2, and we added that to row 1. And then here we divided by 9, and we were finished. So we know that the solution set is 1, 2, and I'll leave the checking up to you. Then in our last example, we want to be able to do this more complicated with a calculator, and I have two different calculator approaches. If you have the TI Inspire, this would be the procedure for the TI Inspire. So our job is to solve this 3 equation, 3 unknown. And I'm using my scratch pad. I want it to look like this. And the way to get this symbol is I'm going to put my cursor in the calculator window and press menu 7, 5. So it's going to give me reduced row echelon form. And then I've got to put a matrix in there, and my matrix needs to be 3 rows, 4 columns. So we're going to do menu 7, 1, 1, and I have to tell it 3 rows, 4 columns to do this. Next, we're going to enter our coefficients. So in row 1, we need a 1, a 4, a 6, and a 21. You can see that here. In row 2, we need a 2, a -2, a 1, and a 4, which shows up in the second row. And then we don't have an A, so a 0, a -8, a +1, and a -1. And then when we get that finished and check with our matrix, then you can click enter, and the system would be solved automatically. And you see in reduced row echelon form, we have that diagonal that has 1s in a triangular method, and here is our solution. X is 1, Y is 1/2, and Z is 3. Now if you are using the Texas Instruments and it's the TI-84, to do the same thing you have different keystrokes, and those keystrokes show up here. To solve that same exact system, you want to press enter the 3x4 matrix by pressing the second button, the inverse button, the edit button, and press 1, and let's name it A. Then we can define the size of the matrix. In this case is 3x4, and these are the steps to get the row echelon form. And once we put those in, we're going to enter the values, and then getting down to the end, it again is going to show us that the Triangular ones are there on the diagonal, and here is our solution: 1, 1/2, and 3. I hope you have good luck with practicing on this lesson. That finishes Chapter 3.